Hello everyone and welcome to yet another recreational programming session with Mr. Zozin. So today we're looking at a very interesting language, which is, I suppose, called Umka. And what's interesting about this language and what caught my attention is that it's a scripting language, but it's a statically typed scripting language, which is rather unusual for scripting languages. So the difference between like a statically typed programming language is dynamically typed programming language is basically when they check the types, right? So statically typed programming languages, they usually check the types before executing the program in the first place. And dynamically typed programming languages, they check the type as they execute. Right. So, and if there is any problem with type compatibility in a dynamic language, if that specific piece of code where the problem exists never executed, that problem is never going to be reported, which in my opinion kind of makes it difficult to refactor things, because I personally rely a lot on statically typed check languages diagnostics to actually find all of the places where I need to do modifications. Right. And what's interesting is that it's also embeddable, which means that it goes into the same territory as, for example, Lua. Right. Lua is also sort of like a small embeddable languages, and it is actually primarily used as an embeddable languages. Nobody really programs in Lua standalone. Nobody, like, I haven't seen anybody actually using Lua as just like a general purpose programming language. Like, nobody does that, seriously, at least. So everyone uses it as embeddable language, right? So you usually have some sort of an engine and you script in that engine. So that's what embeddable language means, right? So you can just take its source code and just like bake it into your game, into your system, into your application, whatnot, right? So, and this is a very interesting combination: statically typed scripting language, but also embeddable, right? And that is very unusual. That is very unusual, and that's what we're going to be doing today. We're going to be checking this language out. So it is written in C and also a little bit of HTML. How about that? It's probably documentation. So, and yeah, so there's some screenshots in here, right? So there's a playground. We're not going to be doing playground. I want to actually build it from scratch. Right, so there's some examples. People have written a ray tracer, right? So that's pretty cool. So this is what you can write in it. Lisp interpreter. So you can have like a 3D games. Is that a ray leap? That's the fastest ray leap speedrun I've ever done in my entire life. It already has a ray leap, right? So it's just like absolute bajonic. I haven't even started yet. I already achieved a ray leap speedrun. That's amazing. Thank you so much. That's actually really cool. All right. So people writing games in it. Okay, so that's really cool. I really like that. And that's amazing, actually. So 3D racing game. Holy shit. Okay, so let's actually clone this entire thing and just like see what we can do with it. So, okay, let's do a little bit of unboxing. Unboxing. Okay, so I'm gonna do le clone. How many commits do we have in here? 1,000 commits. Do I want to clone the entirety of the thing, or do I want to do a shallow clone? So let's actually do a shallow clone just in case, because I don't really want to spend too much time on this kind of stuff. So yeah, the question is going to be, how do you even build this magical language? Okay, so there's literally build Linux. Okay, so, and it already assumes GCC, right? So already assumes GCC, which is fine. It automatically does clean before building everything from scratch. So it builds like a, ooh, since it's embeddable, look at that. Since it's embeddable, it's already builds a library, which you can probably link with. And on top of that, it also probably builds the REPL itself, right? So you have two artifacts in here, the library that you can link with because it's embeddable, and the REPL if you want to just use the language standalone. That's understandable. On top of that, it builds some examples, right? So, and it just like moves things around. I'm really not sure what the fuck is all of that, but it's basically builds like a distribution folder, which you can probably just pack up into like tarball and just distribute it. I guess that's what it's all about. And okay, so let's see how long does it take to build this entire thing, right? So let's fucking go. Okay, so we're waiting. I'm not really sure what we're waiting for. So is that because it doesn't report what is it doing? yeah, it doesn't really report what is it doing. I'm not a huge fan when building process doesn't really report what is it doing. Like this is already a minus for me. So let's do git clean fdx, right? So it already created a bunch of things, but what I would like to do personally, honestly, is to just enable tracing, something like this. And I usually also do E. Right, so X enables tracing, which means that it will print each individual command that is executing, and E, it will fail the script when any of the command fails, right? So it's nice to have this kind of thing at the top of the scripts usually. So let's try to build it again, but with reporting now. So, okay, so it was actually hanging because it is compiling all of these things simultaneously. It's kind of interesting that it takes so much time to compile all of these things. I wonder if this is because they are separate sort of translation unit. I wonder what is going to happen if you actually concatenate them into a single translation unit. Would it be faster? And on top of that, they're also using O3. It's probably O3 that is taking so much time. Right. Dunk. I really like how like an additional D actually turned it into Dumka. And yeah, it's taking some time to build this entire thing. Isn't it actually single translation? I think the way GCC works, but do not quote me on that because I'm not 100% sure. I think the way GCC works is that if you provide several files, it actually makes each individual file go through the entire toolchain. Right, it doesn't really, like it parses them separately. It's like separate commands, I think, but I'm not 100% sure. So it took 1 minute to build, which is not that bad, right? So it's a full-blown scripting language and stuff like that. But I think Lua is actually built a little bit faster, if you ask me. So here is le source code. So I'm gonna just download Lua. I mean, if you're going into the Lua territory, you're gonna be compared to Lua, right? So you are basically competing with Lua in terms of embedability. So let's actually compare that to Lua. I think that would be kind of interesting to see. Right, so I think Lua just builds a little bit faster. Right, so, and I'm gonna use a single thread just for the sake of fairness, right? So because we build it with a single thread. So is it going to take 1 minute? It also takes some time to build the entire thing, and it's actually, look at that, 7 seconds on the same machine. Without parallelization or anything like that. If you parallelize the entire build, it's actually will take, like, I don't freaking know, so minus B. With parallelization, it takes 2 seconds. O2, also O2, yeah, I agree with that. So less optimizations and stuff like that. But anyway, so I want to kind of test my hypothesis regarding, like, what if you just make a single Unity build? Is it going to actually... Oh, wait a second, there is a make file. Wait a freaking second. So that means I could have parallelized some of this stuff, but maybe not. Yeah. So here is a bunch of, okay, so here are the source files. Let's create something like 1C, and let's copy paste all of these things in here. Can I put the stuff like that? So if I replace space with a new line, like so, boom, and let's remove some of these things, empty stuff as well, and let's select this entire thing, and I want to include the entire thing like that. So here's one, and in Linux build, build Linux. So here are the source files. So, and instead of building these source files, let's literally build one, which is 1C, and see if it's actually faster. Maybe it's not going to be that much faster. So no such file. So am I being dummy dum dum? Because that's kind of weird. Did you, oh, you, okay, so it did CD. All right, so it CD'd into SRC. So let's move 1C to here somewhere. So maybe that will actually make it a little bit better. Okay, so it didn't build right away because a redefinition of spelling. Aha, that is very interesting. So some sort of a redefinition has happened. So it's not going up. Why? That's interesting. So it didn't cause a redefinition if you just build all of them, but if you concatenate all of them, that causes redefinition. That is fascinating. Okay. So let me go into SRC, Umka types.c. This is 14. So all right. And there's also Lexa. All right, so which is also 14. Yeah, so this is a spelling. Apparently it's not going to be that easy. Multiple global, yeah, okay, so they have to be, yeah, because you provided them as separate files, right? So you provided them as separate files. They were treated as separate translation units. So these names were local. This name became local for that specific translation unit, so that was fine. But as soon as you try to concatenate that, that caused problems. This is very interesting. So I feel like I got nerd Snapchat. I got nerd Snap. So can I quickly? I'm really sorry. We're gonna get into its language itself pretty soon, but I want to just test my hypothesis. I really want to test my hypothesis. Does it make it faster? Right. So what we can do in here, we can just say, okay, in Alexa, and as far as I know, in Alexa, there's also forward declaration of spelling. I think there is. No, there is no forward declaration of spelling. Okay, let's put in the score in here. Let's put in the score. If like I'm gonna fix the collision, the name collision for spelling specifically, and if after fixing it there will be another collision, I abandon this entire idea and we're just moving on and just like looking into the language itself. But I just want to try that. I'm so sorry. Okay, so in the Linux build, right? So this is fine. All right, and we are going to take a look at the Valico. Hello, hello. All right, so I'm just trying to build it, and obviously it failed in a bunch of places, expectedly so. All right, so, and this is Umka Lexa. So this is one, there should be another one. We just put underscores in here. So going through all of these compilation errors, and yeah, so that should be enough. So let's do that one more time. So I'm just double checking that everything compiles, everything's fine. And I think it is fine, right? So it would probably report that right away, that something is wrong in here. Umka build. How many lines of code? That's a very interesting question, actually. Let's take a look. So let's do clock. Fuck. Okay, so we'll have to do that clock with a different approach. So not to stop the compilation. 10K. It's a 10K. Yeah, so just a middle-sized project, right? So it's pretty good. Not too big, not too small. Somebody needs to make a Sodium Jungle mix, maybe. All right, so it built, and it usually takes around 1 minute, right? So we already established that it usually takes around 1 minute. But what about the Unity build? What about the Unity build? Let's freaking go. Okay, so no errors so far. No errors so far, which is nice. Maybe, okay, so there's some warnings in here. Output may be truncated, copying to... Why there were no warnings when I... This is fascinating. Maybe uninitialized. Is that because now it has more information and now it can report things better? That is fascinating. It would be really funny if it will become slower. Chat, it may actually become slower. You know why? Because now the compiler has more information to optimize things out. Okay. Well, it didn't change anything. It literally didn't change anything. Very interesting. Okay, so let's actually revert all of that. And I'm really curious. If, for example, I can use the make file, right? So let's do git clean fdx, right? So the git clean fdx, and we're gonna just try to build it with 16 threads. And that should take a little bit faster, right? So because we're building all of these things simultaneously, you should have used the make file right away. But yeah, I think that's a very interesting sort of test just to see how comparable is it to Lua, right? Because Lua is also embeddable language, but it doesn't have a static typing, right? So a type checker usually takes, you know, a little bit of implementation. So, and I suppose that's an additional complexity that is put on top of this language. that is put on top of the language. So with 16 threads, I expect maybe it will cut down the compilation time this time. So hopefully. So we're gonna probably start with a simple hello world, right? So while this entire thing is building. Here's a bunch of examples. I remember there was a tour, right? So tour, take a tour of the language. There we go. So it looks like combination of like Rust and Go and C, but it's primarily inspired by Go from what I can see, right? So at least they themselves, I think, claim that it is primarily inspired by Go, but anyway. So it's a good inspiration, honestly. Go is a good language. Anyways, all right. So what we should do in here. So I'll probably create some sort of a playground. There's already playground folder. Let's create something like foo, right? And inside the foo, I'm going to just have main Umka. What is the extension? So maybe there's, okay, so there's examples in here, and examples should have the extension. Okay, so the extension is actually Let me rename it to like this. Okay, so this is the main. We don't really have any highlighting yet. So this is going to be hello world, right? So do I have to provide a new line? That's a very interesting question. I feel like I do have to provide a new line. Yeah, I do have to provide a new line. Okay, so what we're gonna do, we're gonna try to execute this entire thing. So there should be Umka, wait. So makefile build the thing, but it build it into the build folder. Okay, here it is. Okay, so that makes sense. I'm gonna go in here. So build Umka. Right, so, all right, that's fine. So it just accepts the entry file. I can specify the size of the stack, write assembly listing. I can just do the compilation without any execution, enable warnings, run in a sandbox mode. Fascinating. Okay, so what do we have in here? Hello world. That is it, apparently. That is it. So interestingly, it is statically typed, but how much is it statically typed? So what if I put something like a 69 in here? Will that work? Okay, but now if I put a string in here, will that complain? Okay, type statically typed printf. That's already star. That's already star. Some languages can't even do that, despite being fully compiled and statically typed. I'm not gonna point any fingers or anything. Just saying. So that's pretty cool. All right, so that's fine. And yeah, so this is gonna be hello world. Let's do another test. How quickly does it execute hello world? Okay, so yeah, around 9-10 milliseconds. So it's under 60 FPS. So that means I can compile and execute hello world at 60 FPS. So that's totally fine, because 60 FPS is actually 16 milliseconds, right? If I'm under 16 milliseconds, I can do that at 60 FPS. Very useful metric, I know. So assembly is not really typed. By the way, speaking of assembly, you can do assembly listing, right? So that means I can just do something like this. Okay, it didn't do shit, but it output assembly. And I think this is its own intermediate representation, right? Because it doesn't really look like any assembly, right? So it's not x86-64, even though there's push, but I mean, push integer, it's definitely its intermediate representation, right? Hello world per seconds is a McDonald's index of computer science. Yeah, this is true. Hello worlds per second. So yeah, do we have any sort of like, okay, here is the editor support. Sublime. Okay, so I guess we're gonna do like, we're gonna live without any editor support or anything like that. Cool. So let's take a look at the rest of the thing. So Tor, why did it open? Okay, so that's fine. So you can have constants, right? So you can have, and this is how you export thing. So that means you have a system of modules, right? So because you can export things and stuff like that. So that's fascinating. All right, so we can try to write some other things in here. For example, let's write Fibonacci numbers, I guess. Let's try to guess, right? So if it is heavily inspired by Go, I can just try to like raw dog Fibonacci numbers. So here's the first two numbers of the Fibonacci. And does it always require a semicolon? No, it doesn't. It doesn't always require a semicolon, so you don't really have to do that. Okay, so this is going to be something like that, and yeah, that's fine. Even though you can put a semicolon, you don't really have to. But then, if you put them on the same line, it will. Okay, so the syntax is very much similar to Go. It actually goes very much similar to Go. I really like that. Okay, so let's say while a is less than 1 million, and I wonder if it supports underscores in integer literals, right? So this is something that modern languages like to support, right? So something like this. So let's take a look at that. And by the way, since it's inspired by Go, maybe I can use Go mod. Right, so it's not going to highlight FN, right? So it's not going to highlight FN, but maybe that's fine. So you suggest to do something like this. Okay, so let's give it a try. Still works, and I can also try to do something like that. All right, so that seems to be working. Okay. So it didn't uncomment it. Okay, so let's try to do the following thing. So we need to create C, which is going to be the sum of A and B. So then A becomes B and B becomes C. And let's actually print. Is that Fibonacci numbers? I think it is Fibonacci numbers, right? So, and then we're going to print the current A. So we're going to generate several Fibonacci numbers up until this particular value. All right, unknown identifier while. Is that because I have to use for? Because it's literally just, it is just like Go, right? Down to just being only having a for loops instead of while loops, right? Doesn't even have while loops at all. Okay, so this language is very easy to pick up. So far, I didn't notice anything super weird. Right, so yeah, that's kind of cool. You can have arrays. You can have the structures and stuff like that. So yeah. So what is that? Is that a pointer? Is that a pointer? That looks like a pointer. So you can also have methods and switch cases. All right, so switch cases look interesting. So the for loops. So this is just like multitasking. Okay. So, and I think, it's not even multi-threading. Look at that. They don't call it multi-threading. They call it multitasking. So that means it's more like a coroutines. So here is the child. You make, so there is a thing called make. You make a fiber and you capture O. So here is the global A. You capture A. All right. So, and in here, you do some operation and you resume back to parent. So, and then in here, in the parent, you do some things. And if your child is valid, why is it valid? I'm not sure. So that means it's finished or not finished. You switch to that child, right? And then child, so it's a basically cooperative multitasking. So it's a cooperative multitasking. It's called fiber. And I suppose fiber is a type. Okay, so that is cool. That is actually kind of cool. So it's like literally coroutines. It's not really Go routines, right? But it's just a coroutines. And this is a very interesting way of doing lambda, right? I'm not even sure it is a lambda because this is not a parameter for a lambda. It's more of a block. You're passing a block in here. Okay, so in here's the new. We're probably allocating an integer. We're allocating an integer on a heap, right? So that's what we're doing, allocating integer on a heap. And when we're capturing that integer into this sort of block, so is it called closure? So closure definition. Okay, so closure. So they're called closures. Closure definition require explicit list of captured variables. Okay, so that makes sense. That makes sense. So this is what you're capturing. But then how do you accept this is how we do that, right? So this is the lambda, right? So this is the lambda. Then this is the parameters. This is what you return in here. And this is what you capture. That's a very cool syntax, honestly. That's a very cool syntax for that. What you capture in there. Rust-inspired closure. Not really. In Rust, so in bars, you actually put the arguments of the closure. Right, so the arguments of the closure. Here, we're listing the global variables that we're capturing in there. So context is somewhere out there, right? So syntactically, it's slightly different. It's actually syntactically slightly different. But anyway, yeah, that's pretty cool. I want to try this cooperative multitasking. So let me find the fiber, right? So you create the fiber. And let's create the child, right? So first of all, I'm going to create the global variable. So can I just do I have to have the main function? What if I just do something like that, right? So it's not allowed to be like this. So function is not allowed in the constant expressions. All right. So what that means, apparently, it's probably inside of the main, right? So I have to do all of that stuff inside of the main. Okay, that's pretty cool. So can I do that? Okay, so that's fine. Then I'm creating this thing, right? I'm creating this thing. So which is a fiber. I'm allocating the fiber. And another thing is that fiber has to be a closure. It's kind of interesting because there was a closure with a context. And we had to provide a signature in here. But with this closure, we don't provide a signature. It's still the same closure, and it just means that it doesn't accept any arguments and doesn't return anything. Doesn't that mean that I have to do something like this? This is a very weird syntax. Like, why don't we provide in here a signature of the function? Is that a function or not a function? This is a little bit weird syntactically, I think, right? So a little bit unexpected. But anyway, so if I try to just execute this entire thing, cannot destroy a busy fiber. Fascinating. So, so we created a fiber, but it was not finished. And that caused a problem when we tried to exit. So, because it was created and it tried to destroy it. At which point did it try to destroy it, though? Syntax sugar. It might be syntax sugar, by the way. It could be syntax sugar. So, which also means that we could try to do something like this. You can do that, right? So, it is, you're right, it is a syntax sugar. So, can I say that I accept like an integer in here? So, duplicate identifier A. Okay, so it collided. Oh, this is so cool, right? If you have a parameter and a captured thing with the same name, it will trigger an error, a type checking error. This is so cool. So this is cool. Oh, right, incompatible. Okay, so it is, you guys are right. This is literally syntax sugar, apparently. This is literally syntax sugar. Okay, so a busy fiber. Okay, so the question is like, it tried to destroy it, but the question is at which point did it try to destroy it, right? So, because make, does it allocate it on the stack, or is there some sort of array AI or whatever? So this is a very interesting question, actually. So we could, I feel like what we have to do, right, we have to, while child is valid, we have to keep resuming the child. And that sort of drains the fiber. You know what I mean? Right, so while it is not finished, I presume that valid means not finished. Right, so valid, not finished. Because as soon as it goes outside of this closure, it will become invalid and that loop will stop. Right, while it's valid, we keep resuming, that child will do a little bit of a work and resume back. And then again and again and again, and this is a cooperative multitasking. So garbage collected, I guess. Maybe it is garbage collected. Is it garbage collected? Garbage. Yeah, the garbage collection mechanism is based on a reference counting, so Umka needs support to weak pointers. Oh. So, it uses reference counting, right? I mean, that's an interesting solution. I mean, I'm not against that. That's just interesting. Statically typed scripting language with reference counting for garbage collecting. Okay. So let me try my hypothesis, right? So is it going to... Okay, so we drained the child, right? So we actually kept resuming it until it became invalid, or aka finished, and now we exited this entire thing, and that actually destroyed the child successfully. This is cool. This is cool. You know why? Because if you have some fibers that have unfinished work, that might be a bug in your application. Right, you want to make sure that all of the fibers finished successfully, and this mechanism basically tells you, right, that you have a bug, you have some unfinished fiber, go resume to them until they're fully finished. And you know why it is a problem? I had a similar problem with knob. When you run a command in knob, and if you run it as a synchronous command, you get a process ID. Then you have to wait on that process ID. It was a lot of... I actually made that mistake so many times when I run an asynchronous command and then I forget to wait on that command, and then I wonder why the command did not execute. Well, this is because the program died before the command managed to execute anything, and the command was killed. This prevents this kind of bugs. This is cool. I really fucking like that. You create a fiber, it's unfinished, it will literally crash because of that. This is cool. That's the generator with yield. Yeah, that's basically yield. So resume is an analog of yield. So we can do like a cooperative multitasking, right? So we can just say that the parent also does a little bit of work, right? So yeah, so here is the thing, for instance. We can put that work in here. I'm not really sure what exactly this work does, but I mean, it does something. Identifier I, well, I mean, yeah. All right, let's fully copy paste this example. This is actually kind of cool. All right, so I wish there was like an Emacs support for this language. Maybe there is somewhere an Emacs support for this language, but it's not super obvious. There's only Sublime. There you go. So that's a cooperative multitasking, right? So you have a parent doing a little bit of work, then it resumes and it goes into the child, then to parent, child, parent, child. So you can use like coroutines and stuff like that. So what's interesting is that it's an embeddable language. You can embed it into different systems, and it has coroutines. So one of the things I want you to test this language on, I want you to actually embed it into Panim, right? You guys remember what is Panim? Right, so it's sort of like an attempt of creating like a Manim engine. Manim is basically an engine that is used by 3Blue1Brown for his videos. And I want you to, at some point, make a similar videos, and I created my own engine, but it never really went anywhere. And so it's just like sitting in there. And the thing is that with this engine is that sometimes I want to do animations, and I want to make composable animations that kind of execute at the same time, but like multi-threading is not suitable for that. Like I need cooperative multitasking to have sort of like animations like that are pieces of code and execute them simultaneously. And it's kind of difficult to achieve in pure C. We tried to achieve that in C++, but it introduced more like code than it actually solved problems, so I actually abandoned that idea. What if we try to embed this language into Panim and use its cooperative multitasking abilities to just maybe make animations and stuff like that? And I think that could be like a good testimony for this language, right? I think it's an interesting idea. So anyways, let me see, how can you even integrate with this language, right? Because we know that it created a static library. So it created a static library, and it also generated a header. So I suppose if I want to make an application that integrates with an interpreter of that language, I'll have to include that header, and link with that static library, right? So let's go ahead and try to do that. So there's a lot of things in here. I wonder how you even do that. So let me see. So I'm gonna go into foo, and I just want to learn how to integrate with all that stuff. So let me create an application. So this one is more of a like a hello, right? So I'm gonna remove this entire thing, and I'm gonna create the main.c. So this is going to be stdio, and let's just create an entry point. So here's an entry point. So far, I like this language, by the way. It's pretty cool for a toy scripting language, right? It's not even that much of a toy scripting language, right? So it feels kind of like a serious scripting language. So yeah, so it's semi-slope language, I would even say, probably. So anyways, let's actually include Umka API.h, and let's see how it's going to go. So I'm going to create makefile, right? So here's the main.c, and if I try to build the whole thing, so it's going to be extra main.c. Toy language for adults. Yeah, so very funny. So Umka API, we'll probably have to specify like where the header files are located. So this is the build, and probably also include, right? Okay, so that seems to be working. So the question is, like, what the fuck do I even do? Like, how do we even execute things? So is it obvious even from the headers and stuff like that? So let me take a look at that. So in the headers, we have a bunch of things, right? So we have stack slot, which is not that helpful. So there's a function context, there's event hooks and stuff like that. So here's the closure, right? So there's some sort of a closure in here. So here are the callbacks. Okay, so there is a type called Umka, right? And I presume that it's literally structured. It's kind of difficult to find it. I suspect that maybe it is a freaking opaque type. Look at that. It is an opaque type, and I don't think, yeah. So the context, you have to create this context thing. Yeah, and it is opaque. You can't go into that. Right. So Umka, and let me see. So there's an allocation, right? So this is just like a callbacks. They're not really useful for us. Okay, so I suppose you can allocate it, right? So Umka alloc. All right, let's do it like this, and this is our Umka, and it doesn't really accept anything, it just allocates things. So I'm going to just take a look at that. Umka equal to that. So here is the thing, and let's see what is going to happen. If I try to build this entire thing, yeah, so linking is not, you know, working. We have to link with libumka. So build, where, nah, brovskis. Okay, so libumka. So libumka, and I want to actually link with the static library, right? So it's not going to work right away, right? So because it can't really find it, it can't find libumka. But if we provide something like build, it will kind of work, right? So it also wants math. All right, so I'm gonna give you math, and everything seems to be working. Okay, so we got an executable, which doesn't really depend on much except libc, libm, and so on and so forth. And if I try to run this executable, there we go, we managed to create an Umka context. Everything is pretty straightforward so far. Everything is pretty straightforward. I really like that. Okay, so libumka, and what we have to do, we have to initialize. Ooh, this is sexy. Look at that. So we even provide the file. So provide the file source string. This one is interesting. Okay, so we provide the context. That is understandable. So let's maybe grab all of these commas. And put them on separate lines so we can see what is going on. So here's the thing. We have to provide the file name, but then we have to provide the source string, which raises the question, don't you read that from a file, or do you read the file name purely for error reporting? Kind of interesting. This is kind of interesting. On top of that, you have to provide argc, argv. Also reserved. What is that supposed to mean? So this is a very fascinating function. And not really sure like what the fuck is all that means. Well, I understand what some of these things mean, but we can always take a look at like how this thing is implemented, right? So who said we can't do that? We literally have the source code. That's the beauty of open source, chat. That's the beauty of fucking open source. You can just take a look at the source code. Let's fucking go. Let's fucking go. All right, so where is the implementation? Where is the implementation? So this is just me using this entire thing, and here is the stuff. Okay, that's cool. That's cool, that's cool, that's cool. So how do you use a file name? So compiler init, right? So it's a British function. It's a British function. Compiler init. I'm so fucking sorry. So where's the? It's not even defined in here. Okay, so can I chat? So find the file in src. So what kind of files can I find in here? So it contains like only C and H. So I'm gonna grab all of these motherflipping files and I'm gonna feed them into E tags. So that created a le tag. Yeah, so here is a le tag. So that means I should be able to now just do this and provide the tags file. And now I can jump around this motherfucker. How about that? How about that? So it feeds it into a file name. Let's take a look at the file name. So I'm just curious what that file... Okay, so you're just feeding that file name into the Lexa, right? So I kind of do it like that as well, right? So we provide the source code and so on and so forth. Okay, so I understand now. I'm not really sure what we're going to do in here. So do I want to feed this huge ass hello into that? I feel like I don't want to do that. So let me rename that to multitasking, right? So this is a multitasking. I'm going to create a separate hello in here, which is going to be just the regular hello world, right? So I don't want to feed a huge thing into that context yet. Why don't you use Google? I forgot about it. So sorry about it. Maybe at some point I will get back to Google and just like, you know, make it usable, but yeah. So let me see. So this is hello, Honestly, I don't even have to put that into files, don't I? Right, I can just like provide this source string right here, right? And you can say that maybe const char source string is literally this entire thing. Who said I can't do that? I literally can do that. And this one is also escaping, so it's a little bit annoying to do it like that, honestly. It's a tiny bit annoying, but I guess, yeah. It's like shaders. I can bake the entirety of this script in here. Embed time. Maybe I could use embed, but it's like, I don't know if it's work with my standard in here. So the stack size. I don't know what I have to provide in here. So let me try to maybe like 4 kilobytes. Is that enough? I'm not sure. So in terms of argc and argv, I feel like I can provide whatever I get in here. So char argv. So this is argc. This is argv. So I can enable a bunch of things in here. So file system enabled. So let me put this thing in here. So file system enabled is going to be true. Implementation enabled. So the only problem I see in here is that like there's too many options. It would be kind of cool to maybe put them behind some sort of like a structure and have a default structure with default parameters. So because it's kind of like a I don't really know what can I provide in here. So there's also warning callback. Do I always have to provide this callback, or can I put a null instead of that callback? That's also a very interesting question. And now, what the fuck is reserved? I have no idea. So there's a lot of unknown in here. Okay, so I want to actually extract the stack size into a separate variable as well, just in case. So, and the reason why I'm extracting that into separate names is that because I don't lose the names of the parameters, right? So there's a lot of parameters, and so if I just replace them with specific specific values, I lose their names, I lose the meaning behind them, right? So, and in here, by the way, it may return some sort of like okay or not okay. So I'm gonna try to put a null in here and see if it is gonna do anything. So reserved, I don't really know. Can I put null in there? So reserve is a pointer to the start of the stack. So why is it not called stack then? So that's a very interesting question. So let's take a look at the implementation of this entire thing. So Umka init, so reserved. It doesn't even reserved. It's not used. This argument, it's literally a reserved argument. You all are wrong. It's unused because... Okay. Fascinating. It's reserved for future, I guess. Maybe that's what's going on here. Okay, so I suppose I can just put null in there, so that should be fine. All right, so we created Umka. So here we allocated this entire thing, and I can just put something like that in here. So this is okay, and is it equal to S, right? So if it's true, we're gonna put a true in here. Otherwise, we're gonna put a false in here. So let's actually see what's going to happen. So I'm trying to build this entire thing. Of course, it doesn't build. Semicolons. All right, everything seems to be fine. You didn't even need like std boolean or anything like that. So let me try to run the entire thing, and everything is fine. Everything is totally fine, right? So what if I introduce now a compilation error? So how can I even do that? So I can say I expect an integer in here, but I didn't provide any integer in here. Will that fail the compilation? So I'm going to try to compile the whole thing, and I'm going to run the... Everything is fine. So I suppose it didn't... Just initializing this thing didn't try to compile that, right? It didn't try to compile that. Okay, so that's pretty cool. So that reserve parameter was locale before, but they removed it. Okay, so that makes sense, right? That makes sense. Okay, so that means, chat, initializing is not enough. After you... Okay, so then you compile the whole thing. Okay, let's freaking go. Let's just try to do that. So here I can do maybe Umka init. Oh, mate. Umka init. I'm so sorry. So this is that, and I can do OK. I can provide Umka, and here we're gonna have Umka compile. Umka compile. And yeah, so that's it. Right. And it didn't compile. Probably because there is a compilation error. Now, if I try to put a world in here, so there should be no compilation, and that succeeded. So it literally checks it, but it didn't print any error, and this is what's interesting. So, and I wonder if that's because I never provided a warning callback, but it's not really a warning callback, it's an error callback. So kind of interesting. How do I access all of these like error things? We can try to... Oh, there is a get error. Okay, so that's kind of cool. So let's actually try to do that. Get error. So I'm trying to compile, and if not okay, I'm gonna try to get error, and I get it out of the Umka context. Okay, so that's pretty cool. So I put it in here, so that's error, and the question is, what the hell is Umka error? It's a structure. Okay. It literally has everything. It fucking has everything, chat. The fuck? So there's also code. I'm not really sure what the fuck is code, but that should be enough for us. So I'm gonna move it in here. And so I'm gonna just print the diagnostic, and I can even print it in whatever style I want, right? So this is gonna be sort of this style. So this is gonna be the line, and in here is gonna be error, and I just provide the string, and that's just a new line. So this is error file name, error line, and then error message. So I'm gonna ignore the rest of the stuff. We don't really need the rest of the stuff, and here is return 1. So if I try to run this entire thing, it succeeded, but now if I put something like this in here, right, so So incompatible types integer. And it pointed at existing file, but the content is actually not file, right? So it's kind of weird in here, but it fucking worked. Like I could, can I start it the second time? Like so far, I haven't encountered any problems, or like everything is pretty straightforward, except that reserved thing. It's a little bit weird, but it works. It does things. It just does things, and it's kind of cool. I guess it is in fact kind of cool. So yeah, let me try to maybe execute this entire thing, right? So this is going to be Umka compile, right? So here is the Umka compile, and let's do the run. And this one's very interesting. So it actually returns an integer. It actually returns an integer, so I'm not really sure what's up with that. It probably has something to do with this main function, right? So, but anyways, so here's the run, and yeah, so we just provide this entire thing, and this is like a return value. I just run the whole thing, and I can say that Umka run is going to be equal to D, and this is return. All right, let's see. Okay, it returned 0, and it actually printed hello 69. Look at that. So we can also put some interesting stuff in here. For instance, I suppose we can put like a line in here. Let's remove this thing, and let's create some sort of frame, right? So we're programming in Umka inside of the C code, right? So we're testing its claim being embeddable language, right? Because they claimed that this is embeddable language, right? They claimed that. We're testing that claim right now. We're testing that claim. So the claim so far that it is statically typed language is true. We just tested that. It's very easy to verify. And is it embeddable? So far, probably yes. And yeah, it is embeddable language. I just embedded it into a C program. Okay, everything is true, right? So it's literally does what it says on the box. So it's kind of cool. So return 69. People are suggesting to just try to return 69. We can try to do that. So let me see. So return 69, and I feel like it's not going to compile because we never said that this function returns 69. So that's what's interesting. All right. So incompatible type void in integer. So what if I say that it returns an integer, and it compiled, it run, it actually didn't run. That's the thing. It actually didn't run because there was no entry point, I suspect. Right, so there was no entry point because this is not an entry point. So if I do it like that, only then it will run. So you can have main, and if main doesn't have the expected signature, it's not going to be an entry point. That is fascinating, which implies that this language probably has what's it called? Function overloading. Does it have function overloading? Is it polymorphic on return types? That's bizarre. Is it? How can we even test that? So can I just do so overloading all right, so here's fn main, and this is, let's actually test that with this thing. So this is going to be printf hello world. Right, so we can do something like build Umka overloading That works, of course, without a new line, but that's besides the point. So if I put an integer in here, right, so what is going to happen? A function must return a value. Okay, 69, let's put it like that. And this is a design flaw, honestly. This is a design flaw. I think what they should do is that if they see a function with the name main and it's not the expected signature, they should probably throw some sort of error. So let's actually test how does it work with polymorphic stuff, right? So if you have foo and I have s, which accepts a string, I don't know how to do strings in here. I'm gonna just like assume that it is string. So and in here we're gonna do printf foo string, and another one in here is going to be foo integer, and this is a foo integer. Is this going to compile? That's a very interesting question, so let's give it a try. Unknown identifying string. So is it str? you can't polymorph it like that. There is no overloading. There is no overloading at all. Yet you can define main that returns an integer, and that is not going to be considered an entry point. This is a design flaw right here. I feel like this is a straight up design flaw. That should be a bug in my opinion. That should be a bug. So yeah. It's not a parameter loading. Yeah, it's not a parameter loading. It's just, it's treated as lack of an entry point, because I suppose according to this language, I suppose you can just have a script without an entry point and it's a valid script. So first bug in an hour into the stream is honestly impressive. Yes, it's not that big of a bug, honestly. It's not that big of a bug, but yeah, I think it should be fixed, and I hope it will be fixed. Maybe you should report that, but I'm not very sure. So let me see. I'll need to think how to properly report that. All right, so I'll just sit down and just like think about the wording and stuff like that. Don't want to like submit low effort issues, right? So I need to put some thought into that. All right, so yeah, because it's very easy to confuse the user with this kind of stuff. And so the question is, what the fuck is an integer then? Some people suggested that maybe it has something to do with the exit, right? So let's put exit 69 in here. Let's put exit 69, and this is not what I want. I want to rebuild the whole thing. Yeah, it is exit. So it is actually an exit. Maybe it was set by the by somebody who worked with that language or works on that language. What about other offense that only differ in return time? I suspect if it doesn't have overloading, it doesn't matter. So it will always be treated as a redefinition of a function, right? So it's just like if it doesn't have overloading, like it's not a valid thing. Okay, so that is in fact an exit code. An exit code is actually controlled by the, I suppose, built-in exit function. So that's pretty cool. Interestingly, if we're going to be embedding this entire thing into Panim, we need to be able to do cooperative multitasking with the C code as well. So how are we going to do that? So we should be able to we should be able to do one sort of like iteration. So that means the script has to expose some sort of a function, right? Some sort of a function that we can call. In API.h, we can call a particular function, Umka context. So that means we should be able to get that function. So that means there should be some API stuff that allows me to get a function. All right. Really like that. So I'm just thinking about the thing, and yeah, there we go. Here is the way to get it. I provide the module. Oh, I need to know the name of the module, though. I need to know the name of the module, and maybe the name of the module is the name of the file or something like that. So okay, so how am I going to do all of that stuff? So this is not an entry point. Well, I mean, I can just like take this entire thing. I can try to take main. All right, so instead of running, I'm gonna just comment out running. So this one is gonna be, this is a cool language, honestly. This is kind of a cool language. It compiles, it's a whole minute, right? It compiles a whole minute. I remember Siphon, when he, like yesterday, when he described this language, he said whether he can amalgamate that language, right? So, and I suppose it's not feasible for his use case. Okay, so probably a lot of people don't know what I'm talking about. Siphon, one of the cool people on our Discord server, has this interesting idea of basically shipping a small scripting language with the C code base. Right, a small scripting language with a C code base. And he writes a build system in that small scripting language. So the idea is, It's kind of similar to Knob, but instead of using C, using a simple scripting language. The idea is, with the C compiler, build the interpreter of that scripting language, and then run the build script with that interpreter. And it kind of achieves the same benefits as Knob, but instead you're not programming in C, you're programming in a higher level language, which gives you a bunch of more benefits, right? So maybe it has like even garbage collector and stuff like that. So, and he was thinking, can he use Umka specifically for this kind of use case? And so far from what I see, I think Umka is a little bit too heavy for that. It is still an embeddable language. It is still kind of convenient to embed it into things, but it's pretty heavy, right? You need to, like, it builds for 1 minute, first of all, right? So imagine building a build system for 1 minute. And also the size of this entire thing is 10K. So it is pretty cool for what it's designed for, but I think it's a little bit heavy for that specific use case. It's a little bit heavy for building a build system, right? So that's the conclusion so far. Which doesn't mean it's a bad language. It's pretty interesting and cool language, right? So it's just like it's not suitable for that very specific use case. Something like Lua might be more suitable for that. And as far as I know, he found even smaller languages than Lua, right? So that built within like a second or so. And anyway. So the question is, what is going to be the module, right? I'm not quite sure what is going to be the module. So let's maybe put a null in here for now. I suppose it could be the name of the file, right? So here I've just provided like hello. Maybe it has to be hello. But for now, I just want to put a null in here and see if it's going to fail. So what I want to get in here is the main function. And here is this thing. So it's going to be fn. I suppose it is a structure. So I suspect that it might be, yeah, it is a structure, right? So that means I can allocate it on the stack and zero initialize it like so. So then I can get the whole thing in here. So, and if it's not okay, right? If it's not okay, I suppose one thing we can say is that, I'm not really sure. Can I just get an error with this whole thing? Right, can I get an error with this whole thing and just like report it like that? Okay, let's see what is going to happen if I try to do it like this. So okay, redefinition of okay, that's totally fine. Nothing really bad happened, right? So nothing really bad happened, and suppose it succeeded. So let me print the okay situation. Umka get func is going to be, honestly, let's just print fn. Right, so fn pointer, and let's just take it. It's not really pointer. Maybe we can print the contents of that function. Contents of that function. Entry of set parameter result, and it's a stack slot. And the stack slot is. Ooh, this one is interesting. This one is interesting. I'm not really sure how to treat all of that stuff, but yeah. Anyways, so I probably want to print umka get func, and it's going to be s and true. It's not really particularly convenient to copy paste this entire thing, so maybe I could create some sort of a macro in here, boolean to str or maybe to sister, and it's going to be x, and for x I'm going to return true, otherwise I'm going to return false. I want to also put parentheses in here, so okay question mark. Can we just grab the whole thing in here? There's only two of them. Bool to sister, like so, and just remove that stuff. So it's a little bit easier, I think, to read. Bool to sister. This one is okie dokie. Alright, so it managed to get main, so that means having null as a module here is totally fine. What if I put foo in here? Okay, so it caused an error, but it didn't really generate a compilation error. So umka get error doesn't make much sense in this specific context. So I suppose what we want to do in here is just like print okay, right? So okay just indicates that it didn't find the function. So that's what it indicates in here. So that's pretty cool. The question is more like, how do I call this function, especially if I have some parameters and stuff like that. I do remember there was a umka call, right? So that's this thing, and I just call this function, but that raises the question, how do I pass parameters in here? So I suspect the way I pass parameters is by pushing something on the stack. Stack is probably located within the context, right? So there should be something like Umka push, or I don't really know. So there is an add function here. I add the function. So there should be some way to push something on the stack, so you can get parameters. So base type, you can get API. That's a very interesting thing. What the fuck is API? Ooh. So, and what's funny is that it literally casts that. Okay, so that's just these functions. Umka equal Java. I mean, similarities with Java and on a virtual machine. So yeah, and a lot of virtual machines pass stuff through the stack. It's not only Java that does that. In fact, Java didn't really invent that. Java didn't really invent that. It was just for 20 viewers. Yeah, actually, right now it's for 20. For 20, glaze it. Right, so people are glazing. No, not glazing. Anyways, so I need to... I can do parameters, right? So I can get parameters, get up value, get results. So I can just try to do Umka call, and that should just work. That should just work. Except I can't pass parameters, but maybe that's fine. So here I have to provide the Umka itself, the context, and then this thing. And here is the return. Do I have a int return? I commented out in here, so that's totally fine. So it has to be something like this. In fact, I can just do something like that and just call that call, and that should work, right? So almost. So semicolon. Forget the semicolon. And it returned -1. So it didn't manage to call it at all. That is fascinating. So it found the function, but then it didn't manage to call it. And I wonder why. Is that because it caused a compilation error? One thing I can do, if it's negative, I can just try to display a compilation error. So maybe that's what happened in here. Call function is not defined. But you found it. You motherflipper found it, but then you say it's not defined? Okay. That's very interesting. That's very interesting. A get func returned false, I think. Oh, it returned. Ah, fuck. I'm sorry. All right. So what are we getting in here? Oh, yeah. Okay. I'm being a little bit silly. Okay. Everything's fine. Oh boy. Okay, so can I create a bunch of other functions in here? So for example, let's call it nice, and we're gonna accept A integer and B integer, right? So in this entire thing is going to, well, yeah, let's actually make it return something. And essentially in here, we are going to, Emacs, we're going to return sum of A and B. Right, that's what I want to try to do. So here I'm going to take nice, right? I'm taking a nice function and I try to call it, but nothing really happened. So the question is, like, how do you even do that? We can try to maybe have some sort of a side effect. Okay, so let's make it not return anything, but let's have some sort of a side effect. Right, so this is going to be D, this is new line, have to skip that, have to skip that, have to skip that. So I'm going to pass this stuff in here, and there we go. Right. So, and it returned null. So they were set to zeros. So the real question is, how do I pass parameters to this function? Because this is something that we'll need when we are integrating with Panim. So let's try to find anything related to parameters. Okay, so there's a stack slot. So, and I can get parameters from the stack slot, and I have a hypothesis, chat. I have a hypothesis that the way you do that is rather interesting. So here's the params. So within the function, so here's the function context. if you find the function context, here are the parameters, which means that I have to provide a fn params and then the index of the parameter, and I get the stack slot. And within the stack slot, it's a union, right? And I know that it is an integer, so that means I can do something like int value, and I can put 34 in here, and to this one I can put 35. So what if I try to... Easy! Easy fucking peasy! Holy shit! It all makes sense! It all makes fucking sense! I like that! I like this language, it's so fucking cool! Yes, it's just... no bullshit or anything, it's a pretty straightforward API. Yeah. So that's so cool. What if I have some global variables in here? So that's what embeddable means, yeah. I have this interesting idea, right? So if I'm going to embed this language into Panim, I suspect that the script is going to be the animation, and the animation has to have a state, right? It must have some sort of a state. So what if I define a global variable, right? So, and it's going to be a counter, right? So this is a counter, and it's going to be initially 0, right? So we have some sort of a counter in here, but it's a private thing. It is compilable. So then what I can do now, I can increment the counter, and every time I increment the counter, it obviously increments it, right? So, but also it is going to print it. So first thing I do, I increment the counter. I feel like I'm editing the shaders, honestly. It feels like shaders. So, and in here I'm gonna just print the value of le counter. So this is the counter, this is D, and this is the new line. I probably have to escape this kind of stuff as well. All right, so I'm just thinking, do I want to pass parameters? Well, I mean, I already know how to pass parameters, that's totally fine. So the only thing I want to check in here is that, does the Umka context retain its state? So essentially in C code, I'm going to be pulling different functions that it exposes, and it's going to modify internal state, right? And it's going to retain that state between different calls, and this is what we need in here. That's what we need in here. Okay, so here's the function. I'm trying to get the inc, right? I'm getting the inc, and I'm just calling it, right? I'm simply calling it, and I just want to see what is going to happen. Incompatible int. All right, so it's on the line 4, right? So this is 4 integer. Oh, I forgot the counter. Okay. So thank you. This is nice. Okay, having static typing for a scripting language is freaking nice. Honestly, it is freaking nice. So yeah, and it printed the counter. It printed the counter 1. And here is the banger. Here's the banger. So can I actually call this thing twice? What is going to happen if I literally just call the same function twice? It retains the state. It freaking retains the state. Okay, so now I can call it 10 times. What if I literally call it 10 times? So that's pretty cool. Okay. So, and this is printed from the script. This is printed from the script, and this is a global variable inside. Holy shit! This is so cool. And it's so easy to do that, by the way. It's so easy to do that. And so I think we have all of the necessary elements to embed this entire thing into Panim. I'm already streaming for 1.5 hours, so I think I want to make a small break. I want to make a cup of tea, and after the small break, we're going to try to make a Panim plugin. I will explain what it means after the break. And that Panim plugin is literally going to be just like a Umka instance, and the Umka script will be expected to expose some callbacks that the plugin is going to call. And inside of that script, we will be able to use coroutines or fibers or whatever they call in Umka, which will enable pretty cool things with animations and stuff like that. So I think it's going to work out. I do think it's going to work out, but first we need to make a small break. We are back. Okay, so let's try to write a new Panim plugin. So The architecture of Panim is rather straightforward. It consists of two things. It's an engine, right? And the engine is literally just an executable, right? So here's an executable, and I'm gonna try to even run it, and it won't run because it expects a plugin. And the plugin is supposed to be a DLL, or in case of Linux, it's a SO shared object. So, and in here we can try to maybe supply something at maybe this specific plugin. So what this engine does, it just loads at runtime this DLL, and the DLL exposes a bunch of callbacks, and the engine periodically calls different callbacks. Specifically, there's probably something like update on each frame, and that updates the state of the plugin and kind of advances the animation, right? So I have some sort of animation of a Turing machine in here, right? So just like let me run it properly. Okay, so build, there you go. And this is how it looks like, right? So I was making an animation of a Turing machine, and it's basically, this is the DLL that is actually advancing the animation. It also plays sounds, as you can hear, right? So I can even stop the animation. I think I can even restart the whole thing, right? So, and that's pretty cool. So as far as I know, the source code of this thing is somewhere here, right? So here's the plug.c. And it's almost 1,000 lines of code, actually. It's almost 1,000 lines of code. I suppose the main function that we have in here is a plug update, right? So it's a plug update, and it's called on each individual frame, and you're supposed to update your state and so on and so forth, right? So it also accepts environment. If I remember correctly, in environment, I don't remember what it is. So where is this thing? So here is the Panim environment. It's a structure that provides the delta time, right? So it's basically how much time has passed since the previous frame. It also provides the screen width and screen height, and it also tells you the information whether it's rendering or not. And this one is actually rather interesting, because this entire thing is designed to create videos. So that means at some point you can render it. So I pressed R, and now it is rendering, and look at that, it is actually feeding frames into FFmpeg. I don't know for how long it's going to go, but we can wait a little bit. So it's already generated 10 seconds. So it will literally take that animation and it will turn it into a video using FFmpeg. And sometimes the animation probably wants to know whether it is in a rendering mode or not in a rendering mode. So is it finished yet? No, it's actually waiting. So it's oh yeah, it basically went back, it reset, and now I can open this thing in a player. There you go. Here's the video. So this is MPV, right? I'm playing this entire thing in MPV literally. So it turns it into a video. So you can procedurally code an animation with Panim, and then you can ask an engine now render a video out of that. So, and it will work. So, and it uses ArrayLib for rendering. So, and I suppose, I think the way it renders is that when you start rendering, it just takes the code of the plugin and renders it into a frame buffer, and then it takes the pixels of the frame buffer and sends them into FFmpeg. So, and that turns it into a video, essentially. Right, I think that's how it works. So what I want to do, I want to create another plugin that actually allows you to use Umka scripts to define animations and stuff like that. And specifically, I want to try to use the coroutines. So then I can define an animation that is just one function that advances something, right, and another function that advances some another animation. And I want to run them simultaneously using the coroutines, right? I think it's a pretty reasonable thing to try. So that should be kind of cool. Okay, so let's create the plugin literally called Umka, right? So here's the Umka plugin, and I suppose it's going to be a C. So I have a template in here for the C stuff. So that's the template, which is rather convenient. So we can even take a look at how the template looks like, because it's also build. So lib template. So yeah, there we go. Yeah, Panim template. So doesn't really do anything, it's just like renders the text. So we can take a look at the source code of this template. And yeah, so essentially what it does, it creates the camera, right? So it creates the camera and it centers everything. And at the center, it just renders Panim template. So that's literally it. So it has a lot like different things like plug finished. And this is a very important function because through that function, engine knows when the animation is finished. So it knows when to finish rendering the video when it's in a rendering mode. So in here, we are just like loading different things. You can load assets. Ah, I see. So because you need to load fonts to be able to even render you know, the text and stuff like that. Anyways, so let's actually go ahead and put this thing somewhere here, right? So this is going to be Umka plugin, right? And let's go into the build script, and we'll build different things in here. So I suppose the easiest thing to do in here is just like do Umka plug C, and it's a lib Umka, right? So this is a libumka, libubu, and it kind of, I don't like that it kind of collides with the name of the library, libumka, right? So you know what I'm saying? So Umka lang, if you go into the build, right, they're also called, because the language itself is not only an executable, but it's also a library. So I need to call it slightly differently. So I need to call it, let's call it libumka plug, right? So it's a libumka plug. I think it makes a little bit more sense that way. Anyways, so, and in here for this thing, I'm going to maybe change this thing, something like Umka, right? So, and let's try to rebuild the whole thing. Okay, so, and now we do have this specific plugin, libumka, libumka plug SO. And it says Umka. As far as I know, you can also like hot reload these things, but I don't remember the what is it called, the hotkey for that. Let me kind of try to remember it. So here is the shell command. Okay, so what that means, I can put that shell this window in here. Then I'm gonna go into the plugins, Umka. Where is the Umka? Okay, so let's change it to hello Umka. In the Panim itself, where is the entry? Here it is. Is key pressed? I think, okay, so plugin reset. So that's understandable. I think this is reloading. So it's H for hot reloading, I suppose. Okay, that's pretty cool. If now I just rebuild the whole thing and I press H, it says hello Umka without restarting the whole thing. So we can hot reload this entire stuff even. So as far as I know, like the plugin can be notified that it's been hot reloaded, which means that we can also prompt it to hot reload the Umka script. So that's pretty cool as well. So anyways, what we need to do in here, we need to link the libso with Umka as well. How did you hot reload in C? I used DL open. So any operating system come with a mechanism to hot reload DLLs, right? So DLL stands for dynamically loaded library, and it's in the name. It is actually in the name. So essentially with the DLLs or SOs on Linux, you can unload them from memory and load them again, a new version, and continue running from that. So it's not really a mechanism of C, it's more of a mechanism of operating system itself. So in the code itself, we have DL open. So here, this is where we do that, right? Reload lib plugin, we take the path to the DLL, and we do DL open, and DL open is a mechanism of Linux, right? So here's DL open. So dynamic linking library, open and close shared object. We opening it, right? And then through DL symbol, we're searching for specific functions. We're searching for specific functions, and we're just like registering them, and then we're calling these specific functions. So it depends on the SO file. SO file is the input for the program. You don't get it. So your input, which defines animation, is the SO plugin. So you compiling your animation into SO plugin and you give it to the engine, and engine dynamically loads it and run it, and then reloads it if there's a new version. That's how it works. That's how it works. That's how it's been always working. Anyways, so what do we need to do in here? I suppose for the libumka, we need to give it the library itself somehow. So speaking of Panim, maybe, okay, I'm going to do the following thing. I think I'm going to, yeah, copy paste include. So this one is kind of important. I think include only has one file in here, which actually means we probably don't even need the include folder. I can copy the entirety of this file, and I'm going to copy the static library here as well. Right, so that's going to be the idea. And in this place, I'm going to just include umka api.h. Right, how about that? So umka api.h, and I'm going to try to build the whole thing in here. And it built, right, because they're located in the same folder. So I won't be able to actually load anything or anything, but anyways. Okay, so for the plugin init. So this is the function, and engine calls this function. Engine calls this function when the plugin is initialized for the first time, right? So it loads the plugin, calls the lib init, and here we have an opportunity to do something. So in here we're allocating some memory for our plugin context, for our plugin state. This is where we store size. I don't really remember what is size. What the fuck is size? Oh, that is kind of clever. I'm storing the size of the structure, so when if I'm reloaded and the size is different, damn, I even have like a basic migration mechanism, but that's besides the point. Okay, so that's kind of cool. It stores the size of the plugin, so if the structure updates, it detects that and does some basic migration forward. I forgot about that. This is smart. Holy shit, did I come up with that? What the fuck? It's an old code of mine, right? So it's just like, how long ago did I write that? The last time, it's 10 months ago. The last time I updated this thing was 10 months ago, but I think I actually like laid it down like last year, like a year ago. Anyway, so here we probably want to actually have a umka, right? So that's the whole point. That's what I'm trying to say in here, is that we initialize the whole thing, and here we want to allocate umka. So umka alloc, right? So we allocated the umka, and so let me try to do that. Umka init. Yeah, so we have to do this kind of shit. Which raises the question is that where are we gonna be keeping that umka? Probably, let me think. What if we call it plug Yeah. So and in here we're gonna have plug updates. So we're gonna kind of mirror the callbacks of the C plugin. Yeah. So this is gonna be a plug update. And in here, I don't think I'm gonna do anything yet. It's just like a umka plug update, like so. Right. So I'll probably have to put a new line in here. All right. So essentially, all we have to do, we have to do umka init, and I probably want to actually copy paste that code that we did in experiments, right? So here's foo, here's main.c umka init. And I'm gonna just grab the whole thing in here. So for all of these things, yeah, so let's actually grab all of these things, because I kind of want to have the names still. So, and this is a boolean OK, So this one is going to be plug.um, and here is the source string, and I have to actually load that source string from somewhere. So the question is how we're going to be loading this entire stuff. So we probably want to use knob, and I do have knob in here. Can I have knob in here? So if I, yeah. So in knob, there was a function read entire file. So the question is, can I use this function? So let me see. So, we need to read it from this file, which means that we probably want to factor it out to something like this. So let's call it script path, right? So this is a script path. We're loading script path, and this one is script path. So we have to load that into the string builder. So let me put this string builder in here somewhere. So it's going to be allocated on the stack. We are feeding it in here. It may fail, and the real question is, what we're gonna do if it fails, right? So I just realized that the plugin has no way to indicate an error except maybe just aborting. I think that's one way to do that. You just abort the whole thing. Just abort the whole thing and don't worry about it. Okay, so Umka init, we initialize in and if it fails, right? So if it's like not okay, we also abort the whole thing. Yeah, so that should allow us to do that. But by the way, after loading it into the string builder, it's not null terminated. So I suppose source string is expected to be null terminated. So what we have to do, we have to append null into the string builder, right? And then we can turn the string builder into the string like that. Interestingly, we didn't even try to compile the whole thing. We didn't even try to compile it. So which means that, yeah, let's try to compile the whole thing. So if it doesn't compile, we should not kill the whole plugin, right? So we should let the user to try again, right? And we should have something like to reload the whole thing. By the way, this string builder, it allocates memory, right, on a heap, but the structure itself is on a stack. And I feel like we need to be able to reuse this entire thing. We need to be able to reuse this entire thing, which means that we probably want to keep it in the plugin structure, which is a state of the entirety of the plugin, right? It's a state of the entirety of the plugin. So this is a source code, and if it doesn't work, we just abort that. Then we have to try to compile the whole thing. So Umka compile. So where's the compile? Here is the compile, and it may fail, and we'll have to report that thing somehow. So yeah, so this is that Umka compile. So this is p Umka, and if it fails, let's report the error. Let's report the error. But we're not going to crash the whole application in this specific case, I think. Right, so we're gonna just say that an error has happened. And ideally for this specific plugin, I feel like it should even report that error somewhere on the screen. But I mean, it's too much time to actually implement this kind of system, so it's going to be a very simple system, which looks like this. Anyway, so it's probably not going to compile yet. We need to go to the compilation errors now. So how does the SB ever free its resources in C? Well, that's the neat part, it doesn't. Right, you don't always have to free all of your resources all the time. Okay, so what if I include knob.h? Can I use knob.h in here? Okay, so unknown type. So I can probably do something like this. Knob strip prefix. Okay, so what else do we have here? SB. So SB is located within this thing. Umka is located within this thing. argc-argv is rather interesting. We don't have argc-argv, so I suppose I'm going to put 0 and null in here, or at least argc is going to be 0 and char argv is going to be null. Right, so let me see, what else do we have in here? It's part of the plugin state. This is also part of the plugin state, that's totally fine. So boolean, you don't semicolon, forgot the semicolon. Right, now we have a linking error, right? So we have a linker error, so that means we just have to link with all that stuff. Okay, plugin C. This one is a little bit annoying because we have a function that expects like build everything for you, and this is not what I want to do actually. This is not what I want to do. So when it uses libs, and libs, yeah, it always does this kind of shit, which is kind of stupid. So I suppose for now I'm going to just hardcode path to Umka, right? And honestly, let's actually maybe have, yeah, let's just have it Umka as a dependency. So we already have raylib in here. And yeah, that's a bit bizarre. Just a second. I really need to check that. Whew. So it may be something serious. Okay, it's just a spam, don't worry about it. All right, so we already have dependency in here, which is raylib. So maybe Umka could be also a similar dependency, right? So which we put in here, which also means we're going to be linking it with everything, literally everything. So here is the C, and we have C flags. So yeah. So what we have to do is that we use Umka in here. So that's the include folder. And for the library, it's going to be Umka. Just search for it in here, and then just link with all that stuff, lib Umka A. So it's kind of stupid that we link all of them with everything, but that's fine. Okay, so, and it doesn't have knob. So let's do define knob implementation, right? So is it going? Yeah, it seems to be working. It's pretty cool. So now, can I try to run this plugin? Seems to be working, but it couldn't find the plug which is rather interesting. Which is understandable, by the way, because like where does it have to be located? So let's assume that it has to be located in the current working directory, which means that in here, right, we have to move lib to the current working directory like that, and let's freaking go. Okay, so it says hello Umka. That's pretty nice. So that means it managed to like allocate everything properly. So compile, and it managed to even compile everything, right? So that's totally fine. Okay, so the next thing we need to do, we need to find a function in there, right? So let's grab our example, so main.c. So we need to have a function context. Let me go into the plug, all right, and let's say that this has to be plug update fn, right? So this is a plug update fn. So we need to get the function. So here's the compilation. We managed to compile successfully. Module name, let's put null in here, and we expect specifically plug update. And we put it into plug update, right? So here's the plug update. And if we couldn't find that, we have to say something. Right, so we'll put it like this. And here we can say, okay, error script, the script path does not provide plug update. So maybe we could factor it out to something like, I don't know, callback name, right? So this is a callback name, const char, callback name, put it in here. There we go, that's the callback name. New line, let's not forget the new line. And we're not gonna crash, we're gonna just like tell you that something went wrong. But if it succeeds, we should be able to actually call this entire thing periodically, right? We should be able to call periodically. Okay, so now, as we update here, we do a lot of interesting things in here, which we probably shouldn't do. We don't really care about them. And I didn't check one important thing, by the way. I didn't check one important thing. How do I call a C function from Umka? So there should be some sort of a way to do that. There should be some sort of a way to do that. So I remember there was something like add function. Let me find it. Yeah. So there's an extern function. Okay. So an extern function. Okay. So it's a function that accepts parameters. Okay. I think we can work with that. So, and the reason why I want to do that is because I want to allow the script to just call like some of the raylib function maybe, right? So, but we'll have to wrap them into this kind of thing. But anyways, so one thing we probably want to do, I want to like have a function like a draw rectangle. Umka, boomka, software development. Yes, exactly. Anyways, so we need to take the plug update fn, and we have to call it. How are we going to be calling it? Where is my example on calling le fonction? So that's how we call them. So here is the function. I just pass it in here. And I suppose the error is negative, right? So if it errors out for whatever reason, we're just like printing the error and maybe aborting. So that's what we're going to be doing. Maybe aborting. Abort. Okay, so let me see if it is compilable now. So let's go to the compilation errors. So it's within Umka plug update fn. All right, so that's what it has to be. All right, so what else do we have? It's this thing. What else? Yep, so unused variables, that's totally fine. So we have this stuff, which is a foreground color, so let's remove that. Environment is unused, but maybe that's fine. Okay, so now we're calling the Umka function on each individual frame. We're just calling it on each individual frame, and we can, what we're doing, we're just printing this entire thing on each individual frame. Okay, so now if I try to execute the whole thing, it is printing plug update. So it is calling this function on each frame. So now you can do things on each individual frame. Okay, so within the script, we can have some sort of a state. For example, we can have X, which is 0, and Y, which is also 0. So on each update, what we can do, we can increment it by 1. Let's actually keep it maybe integers, right? So we increment both of these things by 1, and let's have something like a draw rectangle. All right, maybe just draw rectangle. Right, and this one is going to be essentially like X, Y, right, and maybe 100 and 100, right? So let's call it draw red rectangle, right? Draw red rectangle. So if I try to now execute the whole thing, it didn't succeed, right? So because unknown identifier draw red rectangle, so we don't have such function. We have to define such function in C, right? So we have to define it in C. So let me see, draw red rectangle. And according to Umka itself, right, so external functions should have this specific signature. So let's literally call it like that. Let's call it, did I forget the semicolon somewhere? Well, I mean, semicolons are not important for Umka. Okay, so this is the parameters and this is the other stuff. So how do we get parameters? So param, I already removed that code that is responsible for taking parameters. So what we have to do, so api.h, get param, it's called params, or just param, get param, so that's the thing. Okay, so I supply the parameters that I got in here, and I'm gonna expect 4 parameters, right? So this is the first one, this is the 0, and I expect them to be integers, right? I just expect them to be integers. And in a slot, in le slot, where is the definition of a slot? Intval. Okay, so I'm going to expect it to be intval. So this one is going to be, I can make it an integer, right? So it will basically truncate, it doesn't matter. So y, width, and height. So this is basically the parameters, and I can just do draw rectangle. Draw rectangle, X, Y, W, H, and literally red. So we can maybe nice to actually pass the color maybe as a string, but okay, so more complex types are passed as void stars, so maybe that's how we do integers and stuff like that, but anyways. All right, let me recompile the whole thing, and it didn't work because I didn't add that function. Just, you know, defining that function is not enough. You need to do add func. This is what I remember. Okay, so pretty straightforward actually. Not that much bullshit. So plugin it. So here's the plugin it. After everything successfully compiled, what we have to do? We have to add this function. P umka. So this one has to be draw a red rectangle, and the function is draw red rectangle. It's probably defined down there, so let's bring it up there so we have an access to it. By the way, it doesn't have to be outside of the translation unit. We can make it static. So, and that should be enough. All right, so let's give it a try. Let's try to recompile the whole thing one more time. All right, so it didn't compile, but that's fine. So param, oh, it's called params. Params didn't work. Unknown identifier, still an unknown identifier. Fascinating. Okay, okay, okay. Is that because, oh, is that a compilation though? Probably that error happened at the compilation time. So let me take a look at that. So this does look like a compilation error, which means that I probably have to add that function before trying to compile. That's very interesting. That's actually very interesting. So draw rect, right? So because look, I first compiled it, then I took this function and then I added. So I probably have to first add this function and only then try to compile. Otherwise, it's not going to type check. All right, let's fucking go. And still didn't work. Ha! That is fascinating. Okay, okay, okay. So I'm confused now. Like I don't know, right? So it just can't find it. Nice, dry and protected. Yeah, too protected, I would even say. Do you have to create an extern FN in Umka? Maybe. So let me see. So extern. So let's take a look at, maybe there's some examples. Lisp. Let me maybe go into the third-party Umka. Let's try to search for extern. Actually, we can try to search for adding the function. Right. Add func. Is there any examples within this thing on how to add stuff? All right. RL drop lane. Okay. So this is the function that they add in. All right. So drop lane, is it declared somehow anywhere? So externally declared function is just like you just declare it like that. Okay, so also it's exported like this, but I never have to export anything, but that's fine. All right, so let me try to do the following thing. Fn draw red rectangle. So, and we're gonna have x integer, all of them are gonna be integers. Right, so x, y, w, h. So I think this is valid. And this is basically external thing. All right, so what else do we have? The fuck? Okay. All right. Easy fucking peasy, meine Freunde. Absolute bagabajuting. Hell yeah. So yeah, and that is updated through the script. Cool. So the thing is, I want to test out the fibers and shit. But to test out the fibers and shit, I need to have something like a plugin need, I suppose. Right, so let's actually introduce plugin init. Right, so here's the plugin init. And we're gonna expect this thing to be called when the plugin is initialized, right? So in a plug.c, so we already embedded it in Panim, by the way, just saying, right? So it's already kind of achieved what I wanted to achieve in here. So here's the init, and we're gonna do a similar thing in here. Look at that. So call back, by the way, I can probably do something like this, and just grab this thing, and replace update with init. So, and after that, we can just call this thing, I suppose. So call Umka call. All right, so we're calling what? We're calling init, but only once. That's what we're doing. All right, so let's fucking go. Okay, so it worked, but it complains about some things, but that's totally fine. That's totally fine, brovskis. Okay, another unused thing, which is environment. Okay. All right, cool. So what I want to do, when we're initializing, we have to just create a fiber. So what I want to do, I need to store the context somewhere. So the way they do that, by the way, it's actually rather interesting if you take a look at their multitasking. If you take a look at their multitasking. So the fiber itself doesn't seem to store. Oh, I think it can store things. I think it can store things. By the way, if I have a capture, if I have a closure that doesn't accept anything, doesn't return anything, it doesn't capture anything, can I just like not provide this thing at all? That's a very interesting question. So I want to test it out. So I'm going to go into the third party, Umka foo. So I'm going to create a foo and maybe in main. So here I'm creating le fiber and I'm going to resume it only once. So this is going to be something like this. So I'm going to do that. I do not capture anything. If I don't capture anything, can I just do it like that? That's a very interesting question. Okay, so I'm going to try to do Umka. Aha, so it's a busy fiber. So if I resume it only once. Okay, so something didn't work as I expected. All right, it's still busy though. What if I resume it a couple of times? Okay, so that's fine. So essentially what happened is that I resumed it, execution went here, right here, then it stumbled upon resume and resume it back, but it didn't finish the child. So then I did another resume and it continued in here and then exited the fiber and finished the fiber. So that's why you have to call resume twice. But this answers my question, right? So if I don't capture anything, I can just have this as a block, which is pretty cool, honestly, which is actually rather cool. So, and I probably can even store some state in here, and that's kind of important. But anyway, so let's go into the plug. So my point here is that if I want to create some sort of an animation, right, what I can do, right, so this is anim, I just make a fiber, and I do the execution here. I allocate X and Y actually inside of this thing, right? I allocate it inside of this thing, 1, 2, 3, 4. And this is my state. And I probably can do something like this, obviously, right? This is my state. And in this state, I indefinitely just update that. I just do this thing, right? So that's what I'm trying to say. I just do this thing indefinitely. So, and that's just a single fiber. And this thing is kind of global, but I still feel like I probably have to initialize it like so. Right, will this work? I feel like initializing the global variables like that is not going to work. By the way, let's put it in here just in case. Let's put it in here. So let me try to compile the whole thing. Okay, let's fucking go. Segmentation fault, and this is because function is not okay. So something went wrong and it just like didn't work properly. That's totally fine. So how can I say so this is a var, and then I want to make a fiber out of that. So this is a fiber. So this is the animation. Can I do shit like that? All right. Declaration. So that's understandable. Okay, that's cool. That's cool. Okay, so I put the entire animation into a fiber, and now what I have to do, every time I render a single animation, I have to resume it. And in here, every time I do update, I have to resume the animation like this. So as you can see, I'm resuming it. It goes in here, it does a little bit of work, and then resumes it back in here, and it exits the function and exits into C code. right? So that's cool actually. Look at that. So here's that. So I probably could even specify the initial parameters and the direction. So okay, I can do something like this: dx dy, and this one is 1 1, and this one is dx dy. Okay, so this is first animation, right? Animation 1, and this is animation 1. I can actually maybe have animation 2, right? So here is the animation 2, and in here, animation 2 probably starts from, I don't know, x500 and moves in an opposite direction. And look at that, I'm resuming animation 1 and animation 2, and now I'm executing them simultaneously. But this is not multi-threading, this is cooperative multitasking, and it's working. So now I can have just a single logic. Right, I can probably put that logic somewhere. I don't freaking know. Like, I need to compress this stuff. Okay, so can I have a function moving red rectangle? Right. So, and let's say maybe it accepts x and y dx and dy as an integer, and returns you a fiber, right? So let's say that it returns you a fiber, and in here, so this one is going to be an initial x, right? So it's called sx and sy for starting. And we're going to capture sx, sy, dx and dy. Which raises the question: is it fine to keep it like that? Maybe it is, right? Sx and sy. All right, so, and in here, it just like returns you the fiber, and I can just return it like that. So now, what I do is just, I make the animation, what is this, moving red rectangle from, starting from 0, 0, 1, 1, and this one, this is basically the parameters. Moving red rectangle, something like that. And yeah, so essentially I have an animation encoded as imperative code, just sequential code, right? This is this sequential code, right? And then I can define two animations like that, and I can kind of execute them simultaneously, but I'm not executing them simultaneously. I'm just resuming on each iteration, given an opportunity for another animation to execute. So this is basically what cooperative multitasking means, right? So, and I suppose that is still working. That is actually still working. I can probably create another animation. Having like separate variables like that is not particularly convenient. It would be nice to have an array of them. It's kind of a form of a sync, right? It is a form of a sync. Should it be, yeah, so it should be sy, thank you so much. But I mean, y was always 0 for both of them, so it didn't create any problems. So arrays, array. So I can create an array of a particular size. So I suppose A is a size. Can I create an array of le fibers, something like that? So Panim. So this is the dynamic array. How do I push into the dynamic array? So dynamic array, how do we push? Fucking, okay, append. Oh, it's just like in Go, you can append. So can you, okay, I'm gonna assume that like literally how you append it. Okay, so we can have anims, and I just append anims just like this. So yeah, so that's how we do that. It's just like in Go. Right, so, and for loop, how do I can actually iterate this kind of thing. So this is going to be for I and anim in anims, and I'm just resuming each individual anim in here. So now I have an array of them. I literally have an array of them, and it makes it super easy for me to add more different things. So let's actually see if it still works. It fucking works. I swear to God. Okay, so now I'm gonna start from this one, and it's gonna be down there, but it moves to the right and up. So now I have a fourth one. That was easier than using C++ coroutines or anything like that, like literally separate language. So, and then here we can have another one. So here's another animation. So now, and I coded that animation. I implemented that animation only once, and I created 4 instances of these animations. And now I'm just doing cooperative multitasking there. Damn, Brovsky! Damn! Holy shit! I love this language. Super cool. So 10 out of 10. It's fucking based. One more time. Can you know when animation is finished? Yes, I can. So essentially, right now it's never gonna finish, but we can do something like, so how do you do for loops? Like for I kind of vaguely remember that you can just like define a variable in here. I less than 5, well maybe let's say 20 frames. So it's going to go for 20 frames, and after 20 frames this capture is going to exit. And if I remember correctly, there's a function valid. So if animation valid, only do that. So essentially this function valid is going to return false if it's finished. So what we want to probably do, if one of the animation becomes invalid, we have to evict it from the global array of animations. I remember there was something like delete. Okay, so I guess that's fine. So you can delete a thing, but I don't know how easy it is to delete things as you iterate them. So if it is invalid, right? So if it is invalid, maybe we could do something like to delete, and this is basically like a fiber, all right? And it's just like append to delete I, and then you just like delete from the opposite order or something like that. Right, but that's kind of besides the point. We can just check without eviction. I just don't want to go into that. It's kind of like finicky, right? And it's kind of besides the point. And it's segfaulted. Look at that. Ha! What's up with this? Okay, so can I just comment out? So let's try to type expected. So that's bizarre for I. Oh, is that because it's a ++? Oh, does it not support? Right, so yeah, as you can see, it did 20 frames. Let's actually put 100 frames. And then they disappeared because they became invalid, right? They became invalid and it stopped rendering them, right? So you can know when it's finished or not. You can know when it's finished or not. Very cool. It is very freaking cool. I think I can do something with it. I think I can do something with that, right? So there should be some sort of a plugin in here for animations. I initially wanted to do Lua, but I think Umka is actually fits for this purpose better. I already implemented. That's already basically the idea that I had for quite some time already. But I thought I'm gonna do that for Lua, but I just did this for this language, and that's so cool. Really like this language. It's a very cool scripting language. I'm already streaming for 2.5 hours, and I think I did a pretty good job reviewing this language. So I guess I'm gonna call it a day. Yeah, thanks everyone who's watching right now. I really appreciate that. Have a good one, and I see you all on the next recreation programming session with Mr. Azores, and I love you all. Mwah.